So this is part 2 of that systems review, test review. So really quickly, I ran out of time, but I wanted to just kind of show you a little better way when we were looking at this one. Okay, a little nicer table. You can see where they intersect, where one is cheaper and then one is cheaper. The difference, right? Spelling, that should have been than. Okay, also if you would have graphed it, it would have looked something like this, starting at 5. Okay, then you would have went up 6 to the right one and kept going, and you can see where they intersect. So that tells you at 5 sessions cost us 35. And you can kind of see, though not very well, but where the orange line is below, right, in this section, and then it's above the purple line. So that's kind of the same idea there. Now let me delete that. So we saw this problem. This is the problem that we somehow skipped. Okay. So a farmer noticed that his chickens were loose and were running around with the cows in the cow pen. He quickly counted 100 heads and 270 legs. How many chickens did he have and how many cows? So we need to take a look at this one and obviously suspend belief that he would have been able to count just all the cows or the chickens very quickly without worrying about their legs. But we didn't. So we think of it this way. So let's call chickens X and cows Y. Okay, so I know that if I take the number of chicken heads and add to it the number of cow heads, that's going to give me my total number of heads. I also know that if I am looking at legs, the chickens have 2 legs, cows have 4 legs. If I add those together, I get 270. Now, you may want to graph these. If you graph these, you would solve for y, right? You'd end up subtracting x here. You'd get y equals negative x plus 100. And you'd subtract 2x here. You get 4y equals negative 2x plus 270 divided by 4. Negative 2 over 4 is negative 1/2. 270 divided by 4 is 67.5. Okay, not the easiest things. And I wouldn't recommend graphing these ones. Because I think once you have it in standard form, I think there's easier ways than graphing, especially with these large numbers. So the first way would be substitution, where right here, that I know is equal to y, so I could have plugged that in for y. I've got 2x plus 4 times negative x plus 100 equals 270. Okay, 2x minus 4 times negative x minus 4x. 4 times 100, 400. Equals 270, subtract 400. 270 minus 400 gives us negative 130 equals 2x minus 4x, negative 2x. So divide everything by negative 2, and we end up with our answer of positive 65. So that tells us what? We have 65 chickens. If we have 65 chickens, I just take this equation and say for cows, it'd be negative 65 plus 100, or 100 minus 65, okay, which would give us our answer of 35 cows. And we'd be done. Okay, so that's using substitution. Graphing, I wouldn't suggest. You could graph those, maybe using a calculator or something like that. If you can do that, more power to you. Okay, but that's using substitution. That is one way that you could do these problems. The other way, so I would choose either substitution or probably elimination. I'm pretty sure elimination would probably be the easiest one for you guys to deal with. So let's take a look at that one. So first thing I need to do is with this, say how do I get the x to equal 2 or the y to equal 4? Well, I'd probably go after the x because I could just double everything, right? So I'd get 2x plus 2y equals 200. Then, positive, positive, we subtract. 2 minus 2 is 0x. 4 minus 2 is 2y. 270 minus 200, 70. 2y equals 70, divide by 2, y equals 35. Okay, so cows is 35. Then we just take one of our equations and say, well, I know we've got 35 cows, so we just subtract it from 100, and we get 65. Now, wasn't that one very quick? Yeah, that's why I like elimination. Tends to be the quickest one. Alright, now bonus question. So Albert, Grong, and Herman have decided to look at getting new phones. There are 3 plans that are available. Albert chooses the Super Data User Plan A, which gives him unlimited data usage for $120 a month. Grong decides to go with the Blinga Bida Data Plan, which gives him a new phone every month for $100 a month, but costs $2 per gigabyte of data used in the month. Herman, who knows his data usage, opts for the Same Data Every Day plan. This plan is $30 a month for the phone with 4 gigabytes of data covered in that plan. After going over 4 gigabytes, the cost is $15 per gig. How many gigabytes of data will they need to use to spend the same amount of money per month? Okay, so now we're still dealing with the systems, but instead of just one, we end up with 3 plans. So we've got to figure out first, basically what it's saying, how many gigs until they spend the same money per month. Well, Albert, we already know what he's going to spend, 120, right? So if we made a table, because I like starting with tables, so we've got gigs used and cost, right? And this is Albert. Well, Albert, let's go to 10. Actually, 12. Albert, doesn't matter how many gigs, he's using 120 all the time, right? So if you were to make an equation for him, what would it look like? Well, this would give us a horizontal line at 120, right? So his equation would be y equals 120. Okay, pretty easy. So what are we trying to find where the others meet? Basically where the others meet 120, right? So Grong, he's got 100 a month and then 2 per gig. So gigs, cost. Let's go down here on this table. I like the table because it seems like it's the easiest to get started on. So at 0 gigs, he's still paying 100 a month, right? At 1 gig, we're adding 2 to that. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're adding 2 each time. So 102, 104, 106, 108, 110, 112, 114, 116, 118, 120, 122, 124. So if we're thinking of his equation, it'd be y equals, well, we started at 100, and then we added 2 multiple times, right? Or 2x plus 100. Okay, which we could have figured out without having to make the whole table. So we could have tried to graph these together. Okay, now this last one, okay, and we can see at 10, that's where we got 120, right? So now he spent as much as his other brother. So now Herman, okay, he pays 30 a month for a phone, but he gets 4 gigs covered in that plan. So here's the way you'd think through his. Okay, so 0, 1, 2, 3, 4. Okay, so at 4 gigs, how much would he be paying? 30, right? And yeah, before that he'd be paying 30, but to make an equation, we want to start right there. So then we'd say it's 15 per gig, $15. So 5, 6, 7, 8, 9, 10, 11, 12. So that'd be 45 plus 15 would be 60, 75, 90, 105, 120, 135, 150. So it'd be y equals, now here's the tough part, okay? Because in order to write our equation, we need to get back to 0. But we know what we're at 4, right? So we could say, we could start at 30, and we would add to that, well, he's adding 15 every time, but he started at 4. Let me rewrite that. So it'd be y equals, we started at 30, we added 15 to that, but then our x actually started at 4. So we'd have to subtract 4 from our x. Okay? So if we simplified this, we'd get y equals 30 plus 15x minus 60. Well, 30 minus 60 would give us 15x minus 30. Okay? So, and the way you could think about that, well, what if we subtracted 30 to get back to 0, right? It would be negative 30. When we were creating our equation, that's kind of how we had to think. But back to our problem at hand. So now, I know at 10 gigs, that's where they're all going to be the same, right? That's what Albert is all the time, but for the rest, for them to spend the same amount of money, they would have to use 10 gigs. Okay, so where do they intersect? Well, at 10 gigs, they're all 120. Okay, and that would be the easiest way to do it, is to make that table, because then the weird one, which was Herman's, is a lot easier to figure out. Okay, and if you wanted to graph it, this is something what it would look like. Okay, here's the equations I used. Okay, I used the more complex equation. You could have made that y equals 15x minus 30. You got the same thing. Okay, so we can see they all intersect there at 10 gigs of data. Alright, there we go. All done with this review now.